What you're going to see is a vodcast on density. We're going to go through the basic idea of what density is and then go through some practice calculations. It's probably a good idea to have a piece of paper and pencil and a calculator while you're watching this vodcast so you can do the problems as we go over them. Please watch the vodcast more than once if you need to. Don't be afraid to pause it in reverse and then bring your questions into class. Okay, what we're going to talk about today is the idea of density. A lot of times when people think about density, they think about how heavy something is. But really it's a little bit more than that. Density is the ratio of the mass of an object to its volume. And this is dependent upon how many atoms are present in a certain amount of volume. So some things, such as iron, have a lot of atoms packed into a certain space, where other things such as, say, cotton have fewer atoms packed into that same amount of space. So the iron has more density than the cotton. Thus the iron is going to feel heavier. Anyway, density has the formula, and let me get a pen here so I can point out some things. Density has the formula mass over volume. And typically our units for mass are grams. Now they can be other units such as kilograms in that, but we'll get to that later. And our volume is going to have one of two units typically, cubic centimeters or milliliters. Now typically when you talk about liquids you talk about milliliters. When you talk about solids you talk about cubic centimeters. But we're not going to stick to that rule. We'll use it more as a guideline. Anyway, so as we said a little bit in the beginning of the presentation, density is represented by the number of atoms in a certain amount of space. So let's say you've got two different types of objects in the same amount of space. Their structure, in other words, the way the atoms are arranged, is going to determine the density. So if you could look at this object and you could see that its atomic structure looked something like this versus something that had an atomic structure where the atoms were further apart, the one that has more atoms is going to be more dense than the one that has fewer atoms. So the density of this object here would be greater than the density of this object here. Density is what we refer to as an intrinsic property, and what that means is that it doesn't matter on how much of the object you have present. So let's say you go down to a lake, and clearly the lake holds a whole bunch of water, and you take one glass full of water from that lake. The question would be, which has the greater density, the water in the glass or the water in the lake? Now clearly the water in the lake total is heavier, but as I'm sure you all know, the density of that water is certainly the same as the density of that water. This is important because things that we can use intrinsic properties of compounds to identify the compounds. So oftentimes in the lab you will use the density to identify what type of object it is. For example, if iron has a density of 11.34 grams per cubic centimeter, and you find the density to be 6 grams per cubic centimeter of an unknown compound, then clearly you do not have iron. We say density changes as temperature and pressure change, but we will discuss that a little bit later. Okay, let's talk about doing some calculations here, which we will do plenty of in this class. Copper penny has a mass of 3.1 grams and a volume of 0.35 cubic centimeters. Now remember, we're not going to worry about whether that's a solid or a liquid. We assume a copper penny is solid, and we're using the cubic centimeters unit for volume. So if we're going to calculate density, density is equal to mass over volume. So we will plug in our values. Our mass is 3.1 grams. Our volume is 0.35 cubic centimeters. When we do the math there, we'll take 3.1 divided by 0.35, and we get 8.9 grams per cubic centimeter. And that's a pretty big density. For reference, the density of water is 1 gram per cubic centimeter. So the density we calculated here is 8.9. We can also calculate the other variables in the density equation. Density is equal to mass over volume. And in this case, we're going to calculate volume. So we're going to rearrange that formula so it's V is equal to M over D. Again, we're simply going to plug in our values, 68 grams over, now we want to put our density here in the denominator, 10.5 grams per milliliter. We'll do the math there, 68 divided by 10.5, and we get 6.5. And our unit left over after we cancel is milliliters, and that would make sense because we're looking for volume. Now we can also calculate, let me thicken up the pen here a little bit. We can also calculate the mass of the object. So again, we're going to take our density formula, mass over volume, rearrange it to solve for mass, and again, simply plug in our values. Mass is equal to 0.85 grams per milliliter. Let's put some parentheses here, and we're going to multiply that by our volume of 5 milliliters, and we get 0.85 times 5, so we would get a mass of 4.25, and again, our units milliliters cancel. The unit left over is grams. So our mass is equal to 4.25 grams. From this vodcast, then, you should get the main points. First of all, you should understand that density is equal to the mass over volume. Density has units of grams per cubic centimeter, or grams per milliliter for that matter. Mass has unit of grams, and then volume, we use milliliters or cubic centimeters. You should understand that density is an intrinsic property. We use intrinsic properties to identify compounds because they do not depend on the amount of the substance present. You should also understand that density is determined by the number of atoms, which we refer to as matter, that are in a specific amount of space. And that you should be able to calculate density using density is equal to mass over volume, but also rearrange to solve for volume and mass. And then what we will cover in the next vodcast is how we go about calculating density in the lab by measuring volume and measuring mass.